Good evening, everybody. I hope that everyone did well on the exam. Based on what I see, your answers in the multiple choices, you did very well. 6 students did the same as in quiz 1. They wait till the last second. I ask them, I remind them many times at 4:59 to submit their answers, but it's their call. However, don't worry, everything is saved and it will be retrieved to the system by midnight. This is how I will do the auto submit. Guys, the transcript will did some problem. If it did the problem, I will stop it. So now, please don't send email that why my mark is 8 in the midterm. This is your mark in the multiple choice part. So this is the mark out of 10. We have 10 multiple choices. Whatever you get, 9, 8, 7, 10. I don't see any student less than 7. I'm not sure, but and some student or a good number of students, they got 10 out of 10. So this is your mark in the multiple choice. The essay question will be marked before the weekend. So maximum by Friday, you will find your midterm mark is available on OWL and you can retrieve it. Also, I hope that by Friday also the proposal mark out of 5 also it will be available on OWL. The TA is working and marking those, but she will stop marking the proposal and as of tomorrow and start marking the midterm. Then she will back to the proposal marking, and I hope that everything by Friday with the proposal will be ready maximum by Monday, next Monday. Now, as you know, that our second quiz will be on, let me open the course outline. Okay, let me share my screen. Can you see my screen, guys?
Yes, Professor.
Okay, so our midterm was today. Then our second quiz will be November 22nd, which will be the last class for material. So based on our syllabus, the last thing will include week 11, the complexities. I will try by next class because we have the 15 class next week, today class and 15 class and the 22nd. So the 22nd at the beginning, we will have a class, we'll finalize the material, then we'll have our quiz. Second quiz. Also, we still have assignment 3, which will be released soon because assignment 3 will cover the topics 1 to 9. So assignment 2, when is the deadline? When we put the deadline?
18.
Assignment 2, the deadline. No, November 16, guys. Be careful. Not 18. 18 for late, which is the 2 days late. So assignment 3 will be released November 16 or November 17. I will release assignment 3 November 17. And you will have like till end of the month to submit the assignment. We will have our quiz on 22nd. And the presentations of the final project will be in November 29th and December 6th. Already you know when you are gonna present. And December 7 is the last day to submit the final project report. Yes. I have some few comments, guys, that during assignment 1, we found, based on the parallelism and code similarity, high ratio of similarity. Try to avoid this in assignment 2. Have your code original, your work. If it is your work, some students, they have 7% similarity, which means it's their original work. Some students, they have 69% similarity. And they said, oh, it's I can assure that I'm honest and it's my code. No. Turn it in, give me from where you get this code. From which website? And some students, they are copying last year's student and the year before. Their colleague work. And it's clear, it show me it's copied from X. Guys, this is based on Western instruction. This is an offense, academic offense. If I report it to the dean office, those students will get F in our course and they will be dismissed from the program. I don't want to like put you under pressure, but try to have your work original. Even I don't have a camera on each one of you to make sure that he didn't get the code from here or there. Even if you try to understand it and write your own code. If you're replacing I with J, A with K, we will get it from where you get this code. Each one writing his code different than the other. No one write the code same as other. And the TA spend a huge time, and myself, to make sure what are the similarities. If it's 4, if it's this one, for sure it will be similar. So we go in deep details and check. But if you even the comment, the same comment after the hash, any one of you, if you want to write a comment or 2 sentences, you write it the same? No, nobody can write the same comment for both. Each one has different mind, he think differently. So please be careful. And also in the report, a lot of you in the proposal that you don't use a proper citation. However, I put it an important comment in the guidelines. You don't use a proper citation. So be careful in your final report also. I want from each one of you to get any possible mark to improve your grade and to finish this course with the grade you deserve and you are willing to have. I told you that I'm not here like to fail a student or to be harsh on them in marking and let them lose marks. No, this is not my way in teaching. I'll be happy if all students got full mark. Which means what I'm teaching you, you are benefit from it. So guys, but there is the most responsibility is upon your shoulder. You are a graduate student, you are not undergrad. So you are mature enough, all of you, to know what I'm talking about, to have your original work, to have your distinguished efforts, to deserve each mark you are getting. Okay, you can use any resource, anything, search the net to find the solution. The most important to understand it. Then you can write your own code to solve an assignment or to write a project or a report in the project. So please, guys, I wish you all the best, always. So you still have assignment 2, assignment 3, project report, the presentation. It's almost more than 50% of the course weight in the mark or in the grade. So please be careful, have your work original. For the project work as a group, as a collaborative group, try to understand each other, try to minimize the conflicts, and work as one team. Then I'm sure you'll get a good mark. So I wish you the best of luck. So this is our plan till the end of the course. Assignment 2 will be released November 17. You have till, I'll give you 10 days to submit it, which means 5 days after the quiz 2. Quiz number 2 will cover week 8, week 9. What we will cover till and week, it should cover all materials till the end of the course. But the last day class, you will have some question, but it would be easy question from that class. So let's start today with object orientation, and we'll move forward. So today we are talking about object-oriented programming. What do we mean by object-oriented programming? What is the object? What do we mean by object? So Python supports many different kinds of data. 1, 2, 3, 4, 3.1459, hello, strings, 1, 5, 7, 11, 13, CA, California, MA, Massachusetts. I couldn't pronounce it well. Each is an object, and every object has a type. So Python, even the integer, even the float, whatever, any data type that you have been introduced to now during this course is considered as an object. And we mentioned this many times. But what do we mean by object? Each object has a type, has an internal data representation, either a primitive or composite. We will see what do we mean by those. A set of procedures for interaction with the object. So the new thing that you have to know that within each object we can associate it with a code that could be run within that object. That's why we call it object-oriented programming. So we encapsulate both the data type with the associated code all together in one entity. We call it object. Object is an instance of a type. It's an instance of a type. 1, 2, 3, 4 is an instance of an integer data type. Hello is an instance of string data type. Everything in Python is an object. So Python, it's a fully object-oriented programming language. So it's considered anything in Python is considered as an object. So we can create a new object of some type. We can manipulate object. How we can manipulate object, we will see. We can destroy objects by using destructor, what we call it destructor. Can destroy object explicitly using del or just forget about them. We can use del to delete it. Python system will reclaim destroyed or inaccessible object called garbage collection. So the new thing that sometimes it's not available in other object-oriented programming languages, that Python system will reclaim any destroyed object, we destroy it, or inaccessible object that we don't access it within our program, and we will send them to a group, call it garbage collection. So this is one of the great features in Python. What are objects? Objects are data abstraction that captures internal representation through data attributes like integer, float, string, whatever, and interface for interacting with object. What do you mean by interface? Through method. For example, what we call it procedures or functions. Define behavior, but hide implementation. So sometimes you will know that this object do the following, but you don't know, but we will hide in our program the implementation, which is associated with that object. And we call this encapsulation. We call this concept encapsulation. We encapsulate, it's like the capsule of antibiotic. You see it as an object, but you don't know what is inside it. And you will just take it with water when you have infection or a bacterial infection, to use antibiotic. So we call this concept encapsulation. We encapsulate the data and the procedures or the interface, which will define the behavior of that object. So you know what goes in and what comes out, but the user don't have to know what's happened inside. It's like a black box. But you as a programmer, you know what the code you put in. Now, example. If we talk about list, how it's represented internally, we call it linked list of cells. So each item of that list has a certain memory cell that contains the value of the entity and the pointer that will point to the next entity of that list. That's why we call it linked list. So if you see here, we have 1, 2, 3, 4. In the first cell, we put 1, and the other part of it, it's a pointer. What is the next entity of that list? It will be 2, and the pointer to the next one, 3, and the pointer to the next one. Follow pointer to the next index of that list. How we can manipulate list? What do we mean by manipulation? Which is the operation that I can perform on that list. So Lij, if we are using two-dimensional list, or I to j, a plus, which is addition, len, which give me the length of that list, min, which is the minimum value, maximum value, del Li, that we are deleting a certain item of that list or entity. L.append, we are appending, extend, we are extending, counting, index, insert, pop, if we are using the stack concept, remove, reverse, sort, and we talk about these operation when we talk about that list in week 6, 7, about those. Internal representation should be private. So anything internal to that object, within that object, which is the list in our example, should be private. What do we mean by private? In object orientation, we have methods or operation that we consider it as a private, public, and in some languages, protected. We'll talk about those. Correct behavior may be compromised if you manipulate internal representation directly. So the behavior, this manipulation and this operation with this object and with these internal operation or manipulation actions that we will take, those will give me the correct behavior, which will be compromised if you manipulate internal representation directly. Bundle advantages of object-oriented. What is the advantages? Why we are using object-oriented? Why we encapsulate the data type or the data declaration or the data declared in my system with the code or associated code as a private behavior within that object? What's the benefits of this? First benefit, we are bundling data into packages together with a procedure that work on them through well-defined interfaces. So we put each bundle of data together with the associated code in a well-defined interface. The second thing, rather than having full code all together, line after line, then I'm distributing or dividing my code into modules, and each module contains this object with their associated data. So we call this concept in a programming divide and conquer development. Implement and test behavior of each class separately. Because a set of objects, we call it a class. So we have the low-level abstract data type that we have in object orientation is the object. The set of same object, we call it a class. Increased modularity. However, I divide my system or my program to smaller pieces, which is what you call it modularity, which is one of the object orientation concepts. Then we are reducing the program whole complexity. We will see in the last handout what do we mean by complexity. Classes make it easy to reuse the code. If I will define the same class that I defined it for before, then I can use it again. And this we call it code reusability concept in object orientation. So it will allow me to reuse the code rather than in each program I have to write the code again from the scratch. Many Python modules define new classes. Each class has a separate environment, no collision in function names. Inheritance, which is one of the most concepts of object orientation that add a lot of advantages to programming, what we call it inheritance, that allows subclasses to redefine or extend a selected subset of a superclass behavior. To give you an example, assume that I'm designing a system for an automotive company. So what my superclass will be, I'll call it vehicle. This company make motorbikes, cars, SUVs, trucks, big trucks, ambulances, etc. So in order to design their system, then there are like the VIN number. It is common with any type of vehicle. Engine number. A lot of things that is shared between any vehicle, whatever its subtype. So the main type or the superclass, I'll call it vehicle. Then I will inherit what I put in vehicle as general, as I call it superclass, to the subclasses. So vehicle class will like represent in the tree a parent class. So the child will inherit its parent specifications, code, data types, all of these things, and I can add or extend or modify some of those features. So I'm reusing the code of superclass with my new class, which will be like a sedan car, SUV car, motorbike class. So all these classes of vehicles will be a subclass of the main class or the parent class, or what we call it superclass vehicle. Is that clear, guys? Now, creating and using your own type with the classes. Make a distinction between creating a class and using an instance. We have to distinguish between creating a class, which consists of different abstract data types like strings, characters, number, whatever, rather than using an instance. Creating the class involves defining the class name. We have to give each class a name. Defining the class attributes. What do we mean by class attributes? What are the basic data types that will be included in that class? For example, someone wrote code to implement a list class. Using the class involved creating new instances of objects. Once I define the class, in order to use what I define, then I have to create an instance, which is an object of that class, instance of that class. That's why first I have to define the class, then I can define instances of that class to use it in my program. Doing operation on the instances, for example, L1, 2, and then len of L. Define your own types. Use the class keyword to define a new type. So we'll use the class definition. We'll start with the keyword class. Then coordinate, which is the name or the type of that class: vehicle, food, beverages, perfumes, whatever you want. Then object, which is the class parent. Define attributes here. Then after the colon, you can start defining the attributes. Similar to def, when we're defining a function, we'll use the word class. Indent code to indicate which statements are part of the class. So normally once you press enter here, it will bring you to here and you will start. If you forget the indentation and you go to that same class, it will be outside of that class's code. So be careful. Indentation is very important. The word object means that coordinate is a Python object and inherits all its attribute inheritance. Next lecture, we'll talk about this. Coordinate is a subset of object. Object is a superclass of coordinate. So these are terms you have to bring yourself familiar with. What are attributes? It is the data and the procedure that belong to that class. What do you mean by attributes? It's any data type that defined within that class, and any operation, procedures, functions that belong to that class. So we have the data attributes, which is the data, and methods, which is the procedural attributes, which is in our most it will be a functions. So the data attributes, think of data as other objects that make up the class. For example, a coordinate is made up of two numbers. These are the data attributes. It's two numbers. Methods, think of method as a function that only work with this class. So these function will work only with these data attributes within this class. How to interact with the object? For example, you can define a distance between two coordinate objects, but there is no meaning to a distance between two list objects. So if we are talking about coordinates, then there is a meaning of distance. But a list of two objects, there is no meaning for the distance. Now, how to create an instance of a class? First, have to define how to create an instance of object. Use a special method called init to initialize some data attributes. So class coordinate object, define init self x, y. What do we mean? Init, it's a special method to create an instance. Is double underscore, be careful. It's double underscore, followed each other. Okay, now self parameter to refer to an instance of the class x and y, what data initializes a coordinate object. So self.x equal x, self.y equal y, two data attribute for every coordinate object. So here, how we are creating an instance of this class. Actually creating an instance of a class, C coordinate 3 and 4. Origin equal coordinate 0, 0. Print C.x, print origin.x. What does those code or line of codes doing? The first one, create a new object of type coordinate and pass in 3 and 4 to the init function. Okay. Then C.x, use the dot to access an attribute of instance C. If you see here, we define x and y. How we will access them? By putting the dot and the instance called C. So C.x. Data attribute of an instance are called instance variable. Don't provide argument for self. Python does this automatically. In some languages, you have to put some argument for self, but Python, the beauty of Python that it's do it automatically. If you are using C or other languages, you have to provide the arguments. But in Python, you don't need. What do we mean by a method? Procedural attribute, like a function that work only within this class. Python always passes the object as the first argument. Convention is to use self as the name of the first argument of all methods. The dot operator is used to access any attribute, a data attribute or a method within that object. Now, we will define now the methods for that one. Now we define a class, we call it coordinate. We put the init, which initiate the instance. Now we'll put the method. The first method, we call it distance. We send it self, refer to any instance, another parameter to the method. So x underscore def square self.x minus other x.x times 2 with times, which means to the power 2, different square self.y minus other.y to the power 2, return the square difference of x plus the difference to the power half. And if you remember, this was in algebra, which is the square root of the x square, x1.
Professor,
Yes.
I'm sorry, the screen has frozen.
So you cannot see my screen. This is because of the transcript that always your colleague ask about it. I don't know why. Okay, just give me a sec.
Thank you.
Can you see it now? Guys, can you see?
It's still frozen.
Still frozen. Okay. Okay, can you see now, guys? Hello, can you hear me?
Yes.
Can you see now my screen?
Yes, Professor.
Yes.
Okay, okay. Okay, so this one was I talking, the distance between 2 points given their coordinates that we have x and y. You know, the law was the square root of the square difference of x over y plus y to the power or the square root of that one. So this is the function that we have. Hello? Okay. So, so this is the function. Other than the self and dot notation, method behave just like function. Take params. Guys, mute your mics.
No, you're talking about the Walmart shift.
Munir and Sampath, can you please mute your mic? So it's like function, take parameter, do operations and return. But we have to add the self and the dot. Excuse me. How we can use the method? Then we have defined distance, self, other, and the code here using the class conventional way. C equal coordinate 3 and 4, 0 coordinate 0 and 0, print C dot distance and send the 0, which is the other one. So it will mark or find the distance between the point 3 and 4 and the point 0 and 0 in any 2D coordinates, which is equivalent to coordinate 3 and 4, 0, coordinate 0 and 0, print coordinate dot distance C and 0, which is the same. Here using the class, here implementing the class. Print representation of an object, for example, C coordinate 3 and 4, print C, 2 underscore main 2 underscore dot coordinate object at uniformative print representation. By default, define a string method for a class. Python call the str method when you use the print on your class object. You choose what it does. Say that when we print a coordinate object, want to show 3 and 4. So print C, it will show you like this. But it will take the uniformative and give you the hexadecimal code of the string. Now you can define your own print. Rather than seeing those, you can define your own print method. So class def str s and self, return str self in this way. So here you define how to return the print rather than getting these things. So here you define your own print method. Wrapping your head around types and the classes. I know, guys, this handout is full of a new concept to you, but next class and the class after, you will be familiar with those. And next class we'll apply some more practical. So next class it will be a bit longer class. So can ask for a type of an object instance, coordinate 3 and 4, print C 3 and 4, print type C class main coordinate. This makes sense. So print coordinate, class main coordinate, print type coordinate, type. Use is instance to check if an object is a coordinate. Print is instance C coordinate, it will give you a true. Yeah, it's an object. So how we check that this is an instance of that object? We will use the function is instance. And we will send the instance like C, what we call it C, and we will send the coordinate to it. Special operation, which is plus, minus, equal, less, greater, len, print, and many others. Where to find those? You can go here to see what are the operations or special operations on classes and objects. Like print can override these to work with your class. So you can define your own rather than using the defaults. So add, sub, equal, lt, len, string, and others. More details, you will find it here with the documentation of Python. Example, fractions. Create a new type to represent a number as a fraction. Internal representation is two integers, numerator and denominator. This is how we represent a fraction in mathematics. Interface methods, how to interact with fraction object. We need to add, subtract, for example. Print representation, convert to a float, invert to a fraction again. This is the simplest method. We get it as a fraction. We will define, we'll convert it to float. Then after we finish, then we'll convert it back to fraction. The code for this is in the handout. Check it out. I put it on the code that I add with each class. You will find it in the resources for week 8. The power of object-oriented, as we said, it's bundled together objects that share common attributes and the procedure that operate in those attributes. Use abstraction to make distinction between how to implement an object versus how to use the object. It builds layers of object abstraction that inherit behaviors. Same example as I said, vehicle, then car, then SUV. So it's making layers. Create our own classes. For example, with SUV, we can say 5-seater SUV, 7-seater SUV, 8-seater SUV, 9-seater SUV like Tahoe. So also we can make different layers. Create our own classes of object on top of Python basic classes. So these are the object orientation concepts with Python. And there are some code examples. Please practice on it. As I told you from the beginning of the course, practice, then practice, then practice. So if you want to understand, you have to practice. Now, so we will start with Python classes and inheritance. We'll continue on the same topic. So we talk about abstraction data type through classes, coordinate example, fraction example. Today, more on classes, getters and setters, information hiding, class variable. I will not complete this handout today because I'll give you more time to practice on the codes that are associated with this handout. You can find it in OWL. For those who don't know, I can show it where it is in OWL. Because based on the OWL statistics, minimal access on the code files. I don't know why, guys, you don't practice, but it's your call. From the first day, we clarify these things. So in resources, you will find the handout here, the link to our video, how to start with Anaconda from the beginning, course outline, and the practice codes. Each week we have a practice code. So for example, for week 8, you will find this example for the fraction, how we can solve it. Example, a set of integer as a class. So you have to practice all of those. If you have a question, get back to me or to the TA. And also for week 9, we have also examples. Animal abstract data type. What do we mean by abstract? Inheritance, use of class variables, how we are doing all of those. But next class, we will apply some codes based on this and this. So implementing the class versus using the class. What is the difference? Write code from two different perspectives. Implementing a new object type with a class, then we define the class, define the attributes, what is the object, define methods, how to use the object. Using a new object type in a code, creating instances of the object type, do operations. So I'm using something I define. Sorry, I define it before. So this is here if I want to implement the class, here if I want to use something is already implemented. So class definition of an object type versus instance of a class. What is the difference? Class name is the type. Here we call it coordinate. Class is defined generally, use self to refer to some instance while defining the class, self.x, self.y. Class define data and method common across all instances. So we define the data and the method associated with these data attributes. Instance of a class. Instance is one specific object. Chord, which is a specific object of coordinate. Here a class, here as an object or instance of that class. Data attributes values vary between instances. C1 coordinate 1, 2, C2 coordinate 3, 4. C1 and C2 have different data attribute values, C1.x and C2.x, because they are different objects. So C1 is different than object 2. They are both. C1 is a different instance of the class coordinate, as well C2 is a different than C1. However, they share that they are an instances of the same class. However, they are different than each other. Instances has the structure of the class, but they are totally different objects within the system. Why use object-oriented and the classes of objects? For example, mimic, real life example. A group of different objects, part of the same time. Jelly, 1 year old, brown. Tiger, 2 years old, brown. Bean, 0 years old, black. This is a rabbit, 2 years old, white. 5 years old, brown. 1 year old, black and white. So they are instances of a mimic class. Now, how we will regroup them, we will see. We will group them. We'll find from mimic, we'll have cats, and the other class, we call it rabbits. Groups of objects have attributes. Recap. Data attributes. How can you represent your object with data? What it is. For a coordinate X and Y values, for an animal, age and name. Procedural attribute, behavior, operation, or methods. How can someone interact with the object? What it does. For a coordinate, find distance between 2 points. For animal, make a sound. So this is one operation. What is the sound of cat? What is the sound of rabbit? What is the sound of dog? Whatever. How to define a class? Again, we are repeating what we have in the previous handout. We call a class, animal, object, which is the parents. Init, to initiate it. Special method to create an instance of that class, self and age. Self.age equal age, self.name equal none. What data initialize an animal type? My animal 1 instance equal animal 3, which is mapped to self.age in a class, because for the name, we don't put the name yet. Name is a data attribute, even though an instance is not initialized with it as a parameter. So we don't initialize it, the name. Can we initialize it? Yes. So class animal, init, age, the name is none, define get age, return self.age, define the get, which is the getter. We call it the getter. So get name, self, return self.name. The setter, here where we set, we'll see now what is the difference between getter and setter. Set age, self a new age, we add a new age, self.age equal the new age. Set name, self a new name, we add the new name, self.name, which is the new name. Define string, self, return animal plus string, and how we will return the name and the age. Getter and setter should be used outside of a class to access data attributes. So we put it outside the class to access the data attribute of that class. So how we create an instance of an object? A equal animal 3. Dot notation used to access attribute. A.age a.getAge. Access method, best to use getters and setters here if we will use the get. Access data attribute allowed but not recommended. So we don't recommend to use this one. Normally we recommend you to get getters and setters. If you want to change the values of that attribute, you will use the setters. If you want to get the information or to retrieve the information, you will use the getters from outside the class. Is that clear? What do you mean by information hiding, encapsulation in some other books? Author of class definition may change data attribute, variable names, class animal in itself, years equal age. We change the age, get age self, return self.years. Replaced age data attribute by years. So you can change whatever you want. If you are accessing data attribute outside the class and the class definition change may get errors. So you have to be careful. If you change the attribute inside the class, so accessing this data attribute, you should be careful with the new names that you choose to change. So outside of the class, use getters and setters instead. Use a.getAge, not a.age. It's a good style, easy to maintain code, prevents bugs. So it will like save you from having bugs in your code by using getters and setters. So how Python is great in information hiding? Allow you to access data from outside the class definition, print a.age, allow you to write to data from outside the class definition, a.age equal infinite, allow you to create data attributes for an instance from outside the class, a.size equal 10. So, but it's not recommended style of programming to do those. You can, but it's not recommended. What do you mean by default argument? For formal parameter are used if no actual argument is given. Def set name, self, new name, self.name, new name. Default argument used are animal 3. So what is the new name? A.set name, print a.get name. It will print for you nothing. This the parentheses. Argument passed in is used here. A equal animal 3, a.set name fluffy, print a.get name, it will print for you fluffy. At the beginning we don't send anything, in the second one we set it. What do you mean by hierarchies? People, student, cat, rabbit. So all are animal or mimics. So we have a parent class animal, child class, which is subclass, which will inherit all data and behavior of the parent class, which is person, cat, rabbit. And from the person class, it's a parent of a student class. So we can add more info, add more behavior, override behavior. So we can override the original behavior and make it a new behavior can suit this subclass. How we inherit? Class animal, def init, self age, self.age, name.none, get age, return self age, name self, whatever, then the new age, the new name, return animal. Everything is an object class object, implements basics operation in Python like binding, variables, etc. So then we'll define a new class, cat. How we inherit it? We add the original class name. animal, which means this is inherited from animal. Here it's inherited from the general class of Python. Def speak, self, print, meow. Def string, self, return how the cat will do, which is the cat. Add a new functionality with the speak. Instance of type cat can be called with the new methods. Instance of type animal throws error if called cat's new method. Init is not missing, uses the animal version. So which method to use? Subclass can have methods with the same name as superclass. For an instance of a class, look for a method name in a current class definition. So if you can use the same like age and name, and you define it within the cat. So if you are calling it and you want to accessing it, be careful to use the new representation with the new names, or the same name but with the new method of the cat, in order to run the method that belongs to the cat, not the original method that available in the superclass. This is what does this mean. Superclass can have method with the same name as superclass. For an instance of a class, look for a method name in a current class definition. If not found, look for a method name up the hierarchy. So if the method you are looking is not available here, then you can go upper level to see where it is, which means that this method is inherited from the parent. Use first method up the hierarchy that you found with that method. So if we have the method within the subclass, we will use it. If not, we will use the main one with the upper level, and you can go, because the hierarchy, there is no limit how many level of hierarchy that you can define within your system. Class person, it's animal, define animal init, self dot set, name, friends, so friend, and here you can define as much as you want. So the parent class is animal, call animal constructor here to initiate it, call animals method, add a new attributes, a new method, I defined it. Here I can override the animals method within a new one. Once we apply all of those examples next class, it would be more clear for you guys. I know that some of you, they never heard about object orientation, right? Anyone did not hear about object oriented programming?
Yeah, I never heard. No.
Yeah, so it's a new concept for you. So it's look tough and difficult. Once you get it from the example and feel it, you will find it easy. Don't worry. Object orientation is a bit a rigid topic at the beginning in the first two classes, but with the practice, you will get familiar with it.
Thank you.
You are welcome. The class is variable and the rabbit subclass. So here we have animal, which is the parent class. We define what to call it tag, which is a class variable. This is the parent class. We define instance variable of it, access class variable, incrementing a class variable changes it for all instances that may reference it. So tag used to give unique ID to each new rabbit instance. So we use, like, in database, the primary key. Here we define the getter and setters. Here the getter methods. And here we will record rabbits in itself, age, parent 1, number 2, parent 2, none. So define the plus operator between two rabbits instances. Define what do we mean by plus between these objects. Define what sum thing like this does R4 equal R1 plus R2, where R1 and R2 are rabbits instances. R4 is a new rabbit instance with age 0. R4 has self as one parent and other as the other parent. In it, it will give me parent 1 and parent 2 are of type rabbits. So guys, try to apply this code, play with it, and next week, at the beginning of the class, we will apply all these codes again, and we will play with it. And if you have any questions, to clarify all these new concepts. But please, from today till next week, try to play with the codes of week 8 and 9. Okay, guys? So how much you practice, and with the Python tutor online, you will start understanding what's going on. And you will find these object, attribute, data attribute, method, class, inheritance, superclass, subclass, getters, sitters. You will be more familiar with it. And once we have another round of examples next week and discussion, I'm sure it will be easier and you will understand the concepts of object orientation. Just think about it. Any object is a set of data types, integer, float, numbers, strings, whatever, plus the method associated with that one. This is the basic principle of object orientation. Why we use it? It's implementing the principle of divide and conquer. Once I have a smaller piece of codes, it's easier to maintain, easier to follow. It reduces the complexity of my program. I can reuse the code I wrote before with different classes, which will give me the reusability of code. All of these things are great things, but since it's a new concept to my mind, I need to practice. Clear, guys? Here they are defining if two rabbits are equal, if they have the two same parents, how we can check that. We'll do it next class. Go through it, practice before we are getting. I'll stop here. We are done with the handout, but we will repeat all the examples next week with open discussion. So object-oriented programming, you create your own collection of data, organize information, division of work, access information. You add layers of complexity, like function classes are mechanism for decomposition and abstraction in programming. As I told you guys, we will repeat those and associate it, but I need from you, I don't give you this task because I know that you have the midterm. So I don't want to mix you with different tasks. So since we are done with the midterm, we cover these topics today. We will come over it again next week. Then we will go to the complexity, introduce the complexity. So you will understand how we reduce the complexity while using the modularity of code, using object orientation concepts. But this requires from you guys to practice on week 8 and week 9. Clear? Questions? Questions, guys? If you don't have a question, you can leave. Thank you, Esther. Thank you. Mahmoush, easy. Thank you, guys. Have a great night and see you next week. But please, again, practice, practice, practice. Okay, Ahmed.
Hi, sir. How are you doing?
I'm good. How are you?
I'm good too. Thank you. Sir, I just had a question regarding the project. When
Yeah.
my topic is actually discussing the time and space complexities of sorting algorithms.
Okay.
So when I'm preparing the report, it comes under the analysis part. So I just want to know, like, how should the template of the report be? Like, what should I include, like a literature review of explaining each of these algorithms, and then I intend of applying it on a
Okay.
data
Yeah.
set?
At the beginning, you will start with introduction. What is the importance of complexity analysis? How we analyze it, and then one of the algorithm that the complexity is very important is the sorting algorithm. For example, you can like have one like half page of literature review that many research going on this area. For example, X dot et al did this one within the sorting, and this et al, and our project will go through these methods and find the benefits and the advantages of analyzing sorting algorithms, for example, in simple ways. So, okay.
Okay. Any, like, should there be like a maximum limit to the report, like how many pages or some?
I don't like to be strict to that amount, but don't write a lot. So we don't have a lot of time to read all everything, okay?
Right.
So to the minimum, but to make the concept clear.
Sure. Okay.
Yeah.
Thank you, sir.
You are welcome. Any other questions, guys, or shall I stop recording? Alvina, questions? Otian Yang, questions? Chia Fu Lee. Hingong. Ben Shen.
Sorry, Professor.
Yeah.
Yeah, I heard you call my name.
Yeah. So do you have any question?
No.
Okay. So you are free to leave.
Okay, I was waiting for other asking. Okay, thank you. Thank you.
You are welcome. Have a good day.
You too.
Robin, do you have any question? Aditi? Junwizi? Hauhan? Benshen? Hingong Ku? Okay. Have a good night, guys, and see you next week.